Assalamualaikum warahmatullahi wabarakatuh. My name is Amira Najha binti Azman, together with my team members, which is Aizat Faris bin Zakaria, and we'll be presenting about identification of fluoride, aluminium, and potassium content in the green tea, which is Camellia sinensis, using the AAS spectroscopy.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Aizat Faris bin Zakaria. Today, I would like to explain about the introduction of the research. As you know, what is tea? Tea is one of most popular non-alcoholic beverage, especially in Asia. Tea consumption, particularly green tea or any other black tea, has risen in this recent year. But today we will be focusing on the green tea research. So, green tea is a tropical, subtropical, and temperate perennial herbs that flourish in tropical, subtropical, and temperate climates. It thrives in cooler temperature around 5 to 25 degrees Celsius, high relative humidity around 80 to 90%, and plenty of yearly rainfall. Do you know tea leaf also can be known as Camellia sinensis, that also most well-known vegetal species that accumulate aluminium. And did you know fluoride is also present in tea leaf as a fluorine ion and is thus less firmly fixed in tea litter, leading to lower quantity than in mature leaf. Aluminium and fluorine were found in high concentration in tea plant leaf, particularly in older leaf. Aluminium and fluorine concentration differ significantly across the various regions and tea plant. You might know that if you come to others country, you might find that there are also different concentration of aluminum and fluorine in this green tea plant. Okay, without further ado, let's move to the significance of research. So, did you know this research is important to observe at the level of aluminum and fluorine in tea, which is Camellia sinensis, by using AAS spectroscopy. Second, it is necessary to determine the component of tea in order to assess the possible advantages and hazards associated in its usage. Okay, next we move to the next part, which is important of analyzing aluminium and fluoride from green teas using AAS. So, as stated as K and Fung et al. 2002, fluorosis has been verified in certain residents of rural region of Sichuan province, PRC, as a result of frequent tea consumption. This is happened because we already know that this Chinese resident always consume this beverage. It's also been discovered that aluminium is a crucial component in the progression of Alzheimer's disease dementia. As we know, in green tea there is a high concentration of aluminium also found by Portugal researcher. Among the various resources for creating green tea, analysis of raw material revealed that all leaves and all leaf with twigs contain the largest quantity of fluoride and aluminium. So, it is important to do research on this component to lower the level of aluminium and fluoride so that people can consume this green tea safely. In future, we can also receive many positive results. Then, this will give the nutritional requirement and or the danger of intoxication associated with their intakes. So, the important to use AAS so we can receive the immediate result of the component.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amira Najha binti Azman, and I'll continue about the AAS method. In this experiment, the instrument that is used in order to determine the result and data is atomic absorption spectroscopy, or well known as AAS. AAS is basically useful to detect the metal ion concentration present inside the samples. According to Lee et al. 2005, the studies is about the new approach to the standard addition method for the analysis of fluoride and potassium content in the green tea. And thus, this method which are preferable and suitable would be AAS, since the content that will be observed in the study is the metal ion. Basically, the specific element can be measured by the amount of light absorbed at the defined wavelength based on the metal ion that you are focusing on the study. The concentration of the metal ion can be determined and calculated by using the Beer's law, where the formula would be capital A equals to A, B, C. Capital A refers to absorbance, A refers to molar absorptivity, B refers to path length, C refers to concentration of the analyte. And the information above is provided by the data that has been collected after you are done analyzing the sample using the AAS. Therefore, this AAS method is specifically chosen compared to others based on the study. Moving on is data and result. So, basically, the data shown below is the one collected from the article. By using the AAS, people can analyze the targeted compound that are needed. So in these studies, it is actually focusing on the fluoride and potassium content inside a green tea. And based on the figure 1, there are two linear calibration observed that indicates the t-test for the fluoride content. So the first line is the traditional standard addition method, and the second one is for the novel standard addition method. And the slope indicates the average of recovery. A low recovery value means that there are interference and other problems occur. And a significant difference can be seen in the figure, as the traditional method has lower value of slope compared to the novel standard addition method. And thus, the calibration graph is precise and correct. Meanwhile, this one is the data shown for the potassium content inside the green tea. So, the concentration of the potassium content can be calculated using the Beer's law formula, which is A equals to ABC. The potassium content of the sample solution is 1.196 mg per liter, and that of a green tea is 1.495 mg per liter when using the novel standard addition. And thus, this new kind of standard addition method proved to have satisfactory precision and accuracy. The next one is the improvements that can be done based on the study. The advantages of using AAS for this analysis is the greater amount of information it provides, such as on the recovery, as well as its simplicity and rapid calibration. Unfortunately, there are some limitations for the AAS. The first one being the limited capability as it only measures one element at a time and limited linearity. This, more time needed during the experiment was conducted in order to obtain the data. There are also some interference that can occur that affects the sensitivity of the AAS. The compound might react with the oxygen during the flame atomization. The only solutions that can be analyzed using AAS, and thus there are a few additional process needs to be taken in order to obtain the liquid sample if the sample that you studies is the raw sample, such as in this case is green tea. And that's it from us. Thank you.